Hi guys, welcome to AP Psychology, and we're starting our modules, starting with Module 0, and this is about research. And believe it or not, this is a very important chapter, even though it's labeled 0, because you are expected to apply all these research terms throughout the entire course to every single theme, every single unit, so get ready. If you don't understand these concepts and terms, make sure that you ask questions in class and really understand them, because you've got to nail them now to be able to apply them later. Something that's really important in psychology is the scientific attitude. Are you curious? Do you want to know how things work? Are you interested in how humans work, how you think, how you feel, how you act, and why you do the things that you do? Curiosity. Number 2, skepticism. Be a little skeptical when you hear information. Don't just accept information as it's told to you. Find out where it's coming from. Who cited the source? Who is this source? And number 3 is humility. Just because you might know a lot about something, don't think that you can't learn more. You're a forever student when you're learning psychology. Just know that the AP Psychology exam will expect you to critically think. And what does that exactly mean? They want you to examine assumptions. They want you to argue different assumptions. They want you to appraise the source and discern hidden human biases. They want you to evaluate evidence. They want you to assess conclusions. They really expect a lot of you, so you have to really work and just, open your mind. In psychology, they also use the scientific method. And here's an example, like if they give you a testable hypothesis, like how sleep might affect your memory. And you might just assume, well, if I'm sleep deprived, my memory might suffer. But why? And we could test this theory. We could test that sleep deprivation actually makes it harder for you to remember things and recall information. So they do expect you to use a scientific method in psychology, just like you would in a science class. So speaking of the scientific method, here we are. We're applying the scientific method to our theory that sleep and memory are somehow related. And that's, we're going to learn later, it's called a correlation. And so if you kind of like make an observation that when you're sleep deprived, you might be cognitively slower, you're not at your peak performance, you're not as fast, and maybe as quick as you might be if you had a good night's sleep. So you ask a question, why is it that when one is sleep deprived that they might be more forgetful? That's a good question to ask. And then we're going to formulate a hypothesis. Lack of sleep can cause memory problems. And then we could actually test it or conduct an experiment. We could test it by giving a memory test while not sleep deprived and then comparing it to another memory test while after sleep deprivation. And then we can actually see, did I prove my hypothesis correctly? Although that leads to some ethical issues. We'll talk about that later. All these terms probably look familiar to you already. You know what a peer review is. You know what a theory is. You know what a testable prediction is, a hypothesis. Something that can be proven false is something falsifiable, right? The possibility that an idea or hypothesis can be disproven. And you know what replication is. The one word on this slide that people have trouble with is operational definitions. And that just means you have to define. For example, we were talking about sleep and memory. We have to define what is sleep deprivation. What is the definition of being sleep deprived? I might define it as having less than 2 hours sleep a night. Someone else might say not sleeping at all is being sleep deprived. Someone might say having 5 hours or less of sleep is the definition of sleep deprivation. We first have to define what is good sleep and what is bad sleep and what is being sleep deprived. That's being clear. So we have to operationally define everything. And that's the one word that kids get stuck on. So when the textbook or a question asks you to operationalize a term, think to yourself, okay, they want me to operationalize a term. That means to define the term very, very clearly. In fact, give parameters to the term. So we go back to sleep deprivation. I might say less than 3 hours or less of sleep is sleep deprivation. That's operational definitions. Okay, to use another example that's unrelated to what we were talking about, sleep, deprivation, and memory, how do you operationally define talking? When I often ask a teenager, so are you going out with somebody? Are you dating? They often say, no, we're just talking. What does just talking mean? And if you're talking to one person, can you be talking to another person? And if you ask a girl their definition of talking and you ask a guy their definition of talking, they might have two completely different definitions. And wouldn't that be nice to be on the same page, especially if you guys both think you're talking? Get it? Talking? Yeah. So talking, if you operationally define it, like lay it out. Like what does that mean exactly? And so you'd find if you actually open up this conversation with somebody, you guys might not be on the same page. Okay, so if you operationalize we are talking, like how long does the talking process last? When does talking turn into dating? Is there a label? Like do you still call each other my friend, or you say boyfriend or girlfriend? Can you talk to more than one person at a time? Do you buy each other gifts during the talking phase? Do you say, hey, want to go to the movies during the talking phase? You have to lay it out. Like you have to really kind of be really specific as to what this means. That's operationally defining talking. Okay, so you have to know what a case study is, and there's going to be a couple notable case studies that we have to kind of memorize these experiments. And as we go through the course, we'll learn them. Naturalistic observation is when you are watching, but you're not touching and you're not manipulating anything. You're just watching. Like if you're watching, for example, chimps and their native habitat, you're just observing. You're taking notes on their, their daily routines and how they eat and how they, socialize with other apes, but you're not going to manipulate, you're not going to interject yourself or anyone else for that matter. Naturalistic observation. You know what a survey is. One of the things you want to watch out for in surveys is how they ask questions and how they word the questions, because they can manipulate the way people answer. Sometimes when people know that their survey is going to be observed and they know that the person who's observing their survey knows the source of the answers, they might lie. And that's like, you might lie because you know what's socially acceptable. And that's what social desirability is about. People are going to answer the survey to make themselves look good, and that's not good because the data would be flawed because they're lying, they're not being truthful or honest. Also, this happens with self-report biasing. When they're self-reporting, they again might answer the question wrong, or they lie, or they exaggerate, or they embellish because they know what's socially appropriate and they don't want to look bad to you, so they might say what you want to hear. So that's called self-report biasing. And notice that when you see surveys, there are certain ways that the question is posed that might manipulate your answer. For example, when surveys are asked to, for example, promoting welfare, are you for welfare or against welfare? The word welfare gets less approval than, say, when people say aid to those in need. See, that gets more approval. Another example is when you say gun control laws, that gets less approval than when people say gun safety laws. That gets better approval because of the wording. And the idea is the same. It's the wording that's really very manipulative. Also, like, look at cars. The word used cars is not as favorable as, say, pre-owned. So watch out when you read a survey, because the way they word it might actually influence your answer. Two words that often get kids confused is the difference between random sampling and random assignment. Random sampling is when you randomly take people from the population for your experiment, but random assignment is randomly putting those people into who's in the independent group and who's going to be manipulated by the independent variable and who's going to be in the control group. That's random assignment. That's different. It's kind of like picking them out of a hat, right? You're in the experimental group, you're in the control group. That's random assignment. But random sampling is taking random people from a segment of the population. Now remember, the population is where you're accessing your sample, and no one ever wants to run into sampling bias. Anything with the word bias in it, you can imagine is something bad. It means that you're not being objective, so it's not favorable to research. And you're going to hear this 1,000 times in this course. Correlation does not mean causation. Just because two things go together doesn't mean that one causes the other one to happen. And remember, in class, I brought up the issue of autism and immunization shots. For a long time, people thought that immunization shots caused autism. There's all kinds of research and many, many studies that say that there is no conclusive evidence that those immunization shots cause autism to occur. But there is a correlation between them. Correlation just means relationship, but it doesn't mean causation. It doesn't mean that one variable causes the other one to happen. Okay, I was just being funny showing you this. I'm trying to find my fingers. Okay, so like the number of people who drown by falling into a pool is actually correlated to the number of films Nick Cage appeared in. Also, the per capita cheese consumption is related to the number of people who died by becoming tangled in their bed sheets. One doesn't cause the other one to happen. Cheese consumption doesn't cause people to get tangled in their bed sheets and die, but there is a correlation. That means a relationship between the two, and that's just a funny kind of example of how correlation is not causation. Here in class, we saw these videos and they were just elaborating and supplementing that correlation is not causation, and they're explaining how correlation is found. But we do have to memorize this. There are three coefficient correlations you have to know: 0, -1, and 1. 0 means that there's no relationship between those two variables. -1 says there's an opposite relationship between those two variables. And 1 means that there's a positive relationship with those two variables. And I often use the example of money, right? When you have more money, you have less problems, right? One hand goes up, one hand goes down. That's a negative correlation. More money, less problems. But if you have more money and more problems, that's a positive correlation because those two variables are going up. But if money and problems are not related, and that's not true. If money and problems are not related, that's a 0 coefficient correlation. So there's numbers attached to those. Those are the ones you have to memorize. Anything above a 0.5 is a strong correlation. So if there's a 0.7 coefficient correlation between your IQ and your parents, guess what? That means there's a strong correlation between your IQ and your parents, because it's a 0.7. It's positive and it's above a 0.5. Just remember those three numbers and you'll be okay. Another kind of correlation is an illusory correlation. And doesn't the word illusory remind you of something? Like illusory. It's an illusion. It's a correlation where you perceive a correlation, but none exists. It's like your lucky bracelet, right? Is there any evidence that your lucky bracelet, when you wear it, you're going to get 100% on that test? No, there is no evidence suggesting that that bracelet gives you magical powers or makes you more smart to conquer that test. But the relationship is real because you believe that the relationship between that bracelet and your test and scoring well in the test exists. It will be a powerful one. So remember, illusory correlations are like superstitions. They're not real, but you're perceiving them as real. So at the end of it all, just remember, correlation does not mean causation, and the AP will just upfront ask you that. They often try to trick you with that premise that you might think that two variables, because they're correlated, actually are related in a causal fashion, and that's there to trip you up. That is there to trick you. So be careful. Correlation does not mean causation, and that's forever true. Do you understand if it's a positive or a negative correlation? The more college students sleep, the better academic performance they have. Is it a positive correlation or a negative one? If you said positive, you are correct, because two variables go up simultaneously, right? The more they sleep, right? Here's my one hand, the better their performance, right? Up, up. When two go up, that means positive correlation. Let's look at the next one. The more vegetables you eat, the less you're going to have mental decline. More vegetables, less mental decline. Hand go down. One hand goes up, one hand comes down. That would be a negative correlation, wouldn't it? Because one variable goes up, the other one's going to go down. The more leafy greens you eat, the less mental decline you have. Negative correlation. The more teen girls spend absorbed online with social media, the more at risk they are for depression. The more time they are online, the more risk for depression. A positive correlation when the two variables go up. Remember, positive and negative in this case doesn't mean good is positive and negative is bad. No, it's just more about math, like two things going up, and then negative is one thing going up, the other one going down. And the last one, the longer children are breastfed, the greater academic achievement they have in school. The longer they are breastfed, the greater academic achievement in school. That is a positive correlation also. So I hope you understand positive and negative correlation, especially with these examples. Okay, so we've talked about correlation is not causation. So how do you prove causation? How do you prove that one variable causes another one to happen? Well, in order to do that, you have to perform an experiment. And when you perform an experiment, there are certain things you have to have. You have to have an independent variable and a dependent variable. You're going to have an experimental group and a control group. And remember, who gets the independent variable? The experimental group always gets manipulated by the independent variable. What's the dependent variable? That's what you're trying to find out, the outcome, or what is being measured. So remember, the IV is the factor you're manipulating, and the DV, the dependent variable, that's what you're measuring. That's the outcome, what you're trying to find out, okay? And so remember, who's in the experimental group? The one that gets the IV. Who's in the control group? The one that doesn't get touched, and they're using the control for a way to kind of like compare and to measure against, but the control is not manipulated by the IV. Very important that you remember that. One of the most common questions that the AP will ask is the difference between IV and DV. Can you figure out what is the IV and DV of an experiment, and can you create an experiment and like show them what is the IV and the DV? The AP expects you to do all of this, so get ready. We're going to be applying these principles throughout the entire course. Okay, so I probably gave you things to practice IV-DV like Kahoots and things like that and videos to watch. Please do it. It's really important that you know. Single blind and double blind, two words that are often found on the AP exam. You have to know the difference. So here is single blind versus double blind. Single blind means the participant doesn't know who's in the experimental group or the control group, but the researcher does. But double blind is the best because the researcher doesn't know and the participant doesn't know. That way it keeps everything objective. Imagine that a person's in an experiment where they're trying to test the effects of THC on your driving ability. If I'm the researcher and I know that you took the THC, I'm going to watch you. You know, it's going to be human nature. I'm going to watch you a little closer than I am going to watch the control group, because I know the control group, they weren't exposed to the THC, but you were. If you were in the experimental group, you were exposed to the THC. I might watch you a little bit more carefully. I might think that that left turn was a little too abrupt, or maybe you're speeding too much. I might not necessarily view you objectively because I know that you have the THC, because I know you're in the experimental group. That makes me biased as a researcher. So in order to keep everything really objective, it's best that nobody knows, right? And the third party can tell me later who was in the experimental group and who was in the control group. It just makes it more objective. It makes it a better experiment. Okay, I already explained the difference between random assignment and random sampling, so I hope you remember. But remember, random assignment is, are you in the experimental group or the control group? Experimental group or control group? Randomly putting people in these two groups is random assignment. Now, if you have an experiment that's both valid and reliable, that's a good experiment. So reliable is going to be connected to replicability, right? If it's reliable, you can do it again and again, and it yields the same results. However, valid means, does the IV really affect the DV? Are we testing what's intended to be tested? And that's when an experiment is valid, and that's a good experiment when you can say yes to those two questions. Last but not least, confounding variables can mess up your study. Like, confounding variables are variables that you can control. Like, what if your sample, what if your participants, they have really strong personalities, they have really maybe tough characters? What if it's really hot in the room? These are things that you can't control, but that can affect your experiment in a good or a bad way. It doesn't even matter, because it's affecting your experiment. And then you know what? It's going to mess up if the IV is really affecting the DV, because you have confounding variables. So the confounding variables could be a list of different things. It could be anything from environmental to participant, like the participant themselves could be a confounding variable. All right, and last but not least, we got the biases, right? Experimental bias. Whenever you see that word bias, it's bad, because it means that you're not being objective. Very important about experimentation is ethics. You must have proper and guide by proper ethical guidelines. One of the things that's very important in the study of psychology is the use of animals. And animal ethics, very important. You have to have proper housing. You have to have minimal pain or discomfort and no cruelty. They have to have proper food and water. They have to have the least amount of the species available for them. And also, if you can choose another species, or you can do a computer simulation, that's even better than using the real thing. It seems like an age-old question, but do violent video games and violent movies make kids violent? Well, we can't really say for sure if it does. There's some people on both sides of the equation. They'll say yes, that violent video games make kids violent, and there's some people who say no, I've been playing violent video games all my life and I wouldn't hurt a fly, and I get it. However, can you test this? Would it be ethical? No, especially testing with children. So when you're talking about psychological testing and research, we have to be really careful with ethics. We don't want to violate ethical guidelines ever, 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 because that would make a very bad experiment, one that can't be replicated. Okay, and you have to know your different research designs. So you have to know different research methods, like non-experimental methods, non-experimental but they're correlational methods, and experimental methods. You have to know their purpose, how they're conducted, what's being manipulated, their weaknesses, and their strengths. So know your research designs. And what are you doing when you're doing an experiment? You are collecting data, but what kind? Qualitative or quantitative? Look, a lot of kids get these two messed up also, but you can easily decipher through them. Look, qualitative, think of the quality of the response, right? It's going to be in depth, but quantitative, think of numbers. Quantitative data is numerical data, where qualitative data is more in depth. So, for example, how many times a person slept and for how long they slept, that's quantitative data. But what did they dream about? That's qualitative data. You can't forget ethics with people also. A person must have informed consent. They have to be protected from harm. You have to keep all information confidential. You have to debrief them afterwards, especially if they were lied to. And they have the right to withdraw from a study at any time. You can't trap them or keep them against their will. Know your ethics. The difference between descriptive statistics and inferential statistics, they're different. Just listen. Descriptive sounds like what it is. It describes something. It's going to be used to measure and describe the characteristics of a group. But inferential statistics, look at the word inferential. It has the word infer in it, right? It's numerical data that allows us to infer information about the sample. That's the difference between inferential and descriptive. And don't forget, meta-analysis. You don't even have to conduct a study. You are looking at different studies and their data and putting it together to come up with a conclusion. Okay, so real quick, just remember that representative samples are better than biased. unrepresentative samples. Bigger samples are better than smaller samples, and the more estimates that you get, the better it is. So sometimes, right, the large effect size means that you're getting better research findings than the smaller ones. The normal bell curve, we've been talking about the normal bell curve since forever. The normal bell curve describes life. Most things happen along averages and few things happen along the extremes. In this slide, I'm showing you IQs. Most people IQ hover along the average of 100. Few people are mentally disabled and few people are gifted, right? The extremes are on the sides. So if you look at the main part, that's the bell part that they're looking at. So most things hover along averages. And the same thing could be said for talent, for beauty, just like we just did the example of IQs. Here's some good news in AP Psychology. We don't have to calculate much, but we do have to know the mean, the median, and the mode of a list of scores. So the mean means taking an average. The median is in the middle, the scores that are in the middle, and the mode is the score that you see the most in a distribution. You might have to calculate the range, which is the difference between the highest and the lowest of the scores in a distribution. You don't have to calculate standard deviation, that's a good thing, but you have to talk about what standard deviation means. And remember, standard deviation is a measure of dispersion, how far away those scores are from the average. When I talk about standard deviation in class, I talk about my grades. For example, having a low standard deviation, you're going to have a very thin curve, which means that most of the scores are going to remain close to the mean or the average. But really in AP, I have a high standard deviation. I have a very fat curve, which means that there's a wider spread of grade distributions away from the average. I have scores as low as 30s and 40s on tests, and I have scores as high as 98%. Almost 100% on the test, and all those other scores in between. So when you have a high standard deviation of a grade distribution in class, that means that I have a wide variety of grades being dispersed in class. It could be because I have a wide variety of different people with different backgrounds and different experiences. So I have a very large dispersed array of grades ranging from very, very low to very, very high. Okay, when you're looking at these scores here, look at the tail. What do I mean by the tail? When you have a left skewed distribution, or you have a left skewed, it could also be called a negative skewed distribution. That means the tail's on the left. That means that the majority of scores are above the mean. If the tail's on the right, check out that tail going to the right. That's called a right skewed or a positively skewed distribution. That means the majority of scores are below the average or the mean. And if you need more help with these statistical terms and you want more examples, look at these videos right here that I've posted and review them, rewind them, and forward them and play them again. Whatever you need to do to remember these terms, it's what you got to do.